This is Randy Allen from Engraving Concepts. We're going to set the beam alignment on the Helix laser system. Also applied to the Mini 18 and Mini 24.
These are the tools needed to perform an alignment on the Epilog laser system. You'll want a Phillips head screwdriver, a medium-sized point, a set of standard Allen wrenches. Specifically, we'll be using the 3/32 inch wrench, and I would recommend using the longer hexagon ball-end wrenches. You'll want the laser beam alignment target that came with the machine. This is a plastic receptacle. It has a plastic engraved target that fits inside the plastic piece. And then some masking tape. You always want to make sure you have, while performing an alignment, you're using some standard safety glasses. For the alignment procedure, we are going to remove the left side panel facing the machine. It has 4 standard Phillips screws on the left side and 2 in the back. So we're going to remove that panel now. And then we're also going to remove the back side panel as well. Now let's remove the back side panel. Okay, so with the back panel removed, to simply identify the components being used here, we have the Epilog laser tube that's mounted to the back of the chassis, and the laser's wavelength is directing the light wave through this chamber, and that is directing the laser beam to this first mirror that's at an angle from this mirror mount. So the mirror mount or path of the laser beam is going from this mirror straight up. Then the beam is directed from this mirror to this mirror and then through the hole that's directed here. And then that laser beam is going to be directed to the steering mirror that's on the carriage. And then that laser beam, as it is directed off of the steering mirror here on the carriage, directed over to the lens assembly. And this lens assembly has a mirror that's mounted here, and then that's directing the beam straight through the lens. So there are 4 mirrors, 1, 2, 3, 4, and then to this lens assembly here. Also, before we begin, we're going to be sure that we have the laser power source plugged back in to the system and plugged into an electrical outlet. We're going to fire up the laser here in just a moment, but also a very important rule is that you always want to make sure you have, while performing an alignment, you're using some standard safety glasses. Be sure you have some safety glasses when performing a laser beam alignment. Alright, so we have our machine powered up. We have the left side panel removed and the back side panel removed. And I'm being sure that I have my safety glasses on. All about safety. So let's get started with this beam alignment. Okay, when performing a beam alignment, there's a concept I want to get across right off the bat. That the laser system is coming out of this side over here. It's coming out of the window of that lens assembly, or the mirror assembly. And that is coming all the way through here. Now, over here you see 2 mirror mounts, one on the top and one on the bottom. Okay, so the major concept of understanding a beam alignment is understanding which mirrors are responsible for the alignment and how they affect the beam at the table. To look at this closer, we're going to show that this mirror on the bottom is the mirror number 1. That is the first mirror that is contacted out of the laser tube at the table. So it comes out of the tube, hits this mirror number 1, then is reflected up, hits mirror number 2 right above it. That beam then is directed straight from mirror number 2 to mirror number 3, and that directs the beam over to the lens assembly at mirror number 4, and then down through the lens. Now, that is the path that the beam takes as it exits the tube to the laser table. A major concept you want to understand when performing a beam alignment is that this carriage that carries the laser beam obviously moves front to back, and the lens assembly moves left and right. The responsibility or adjustments of the two mirrors at this mirror mount are responsible for adjusting the laser beam to be parallel with the table. So the whole idea is to keep the laser beam consistent as it moves back and forth parallel to the table. So as this moves, we want that beam to stay parallel or even. We don't want it crawling up or down. That needs to stay parallel with the table surface. That's also why it's important to keep your material flat as it's engraving. Understanding that these two mirrors are responsible for the alignment or keeping the beam parallel to the table as it moves front to back, it's then important to note that this mirror is responsible to keep the laser beam parallel to the table left and right in the x-axis. So as the lens assembly moves left and right, we want that beam to stay parallel to the table. That's the whole concept, is to be parallel to the table as it moves across the laser cutting table. So let's begin the beam alignment by powering up the unit. That's going to initialize the system in the back left corner's home position. Now the beam alignment procedure that is built into the machine is found in the Mini 18, Mini 24, and the Helix 2nd generation. This built-in beam alignment is not found in the Fusion or the Zing series. So this particular display and the built-in beam alignment is found only in the 2nd generation Mini 18, Mini 24, and the Helix, not found in the Zing or the Fusion series. To enter beam alignment mode on the display of the 2nd generation systems, you'll find that to be maintenance, and then arrow down to align laser, and then push go. When pushing go, that takes you into the alignment mode. The instructions on the display at this stage are, it's telling you to push or tap the up key, this arrow here, to fire the laser. So if we tap the up key now, that is supposed to fire the laser. However, this is only done when the interlocks are all made on the front door and the top door. So you have to be sure that your front doors and top door are totally closed and the interlocks are made for this to work. So as we enter beam alignment, we're going to make sure that our front door is closed and our top door is closed, ensuring that our safety magnetic interlocks are made so that we can tap the up key, and that will then fire the laser at the lens assembly. Also, by going into this mode, this allows the operator, when performing a beam alignment, to move the lens assembly to each corner of the table. So only in alignment mode can we move this carriage front to back and left and right. As we're in the alignment mode, this allows us to move that carriage to every corner of the table, ensuring that our beam alignment is correct. Since we are still in beam alignment mode, we have the ability to move the carriage around front to back and left and right. At this time, we're going to install the laser Bullseye Target that's included with the machine. If you do not have one of these, you need to get in touch with Epilog Tech Support at the factory in Golden, Colorado. This is a plastic receptacle that is placed inside the lens assembly like so. It just pushes right there to the inside of the assembly. Next, we're going to apply a piece of masking tape to our lens assembly over the target. So we're going to place the tape over the target, and what this allows us to do is fire the laser beam from our keypad, also ensuring that we have the real laser and the red dot pointer aligned together. When performing a beam alignment, it's helpful to use your red dot pointer and to take care of the red dot pointer first. So I'm going to push the red dot pointer button on the display, and there we see the red dot is coming out of the back panel of the system, reflecting off the same path the laser beam takes, and it's contacting the laser target. This is at the very front of the machine by the display. Let's take a look around back to see where the red dot's located. Okay, from this angle at the back of the machine, we're looking at the back where the laser tube is located. This is also where our red dot pointer assembly is located, and also you'll notice that there are 3 holes at the top part of the chassis. These 3 holes are used in conjunction with a long ball end Allen wrench, a 3/32 wrench, to help align the red dot pointer to the target that we just placed in the lens assembly. So by slipping the Allen wrench through the hole, we can reach the inside or the adjustment screws of the red dot pointer. Now you're wanting to go ahead and do this first before you begin the beam alignment of the real laser beam, to be sure that you have the red dot pointer correctly aligned at the target. So what you're going to do is, with the red dot turned on, you can adjust these screws, and there are 3 screws, 1 towards the back, 2 on the side, that allow us to adjust, and as we turn that screw, that's going to move the red dot at the lens assemblies, the Bullseye Target. From this angle we can see the red dot pointer that is turned on, and it is positioned right in the Bullseye's target. However, it is off center. So as we begin our laser beam alignment, we're going to start by firing and pushing that up key to fire the laser beam. We're talking the real laser, so that fires the beam into the Bullseye target. Then we're going to adjust that red dot to the real laser. Not really concentrating that's in the center of the target right now, but we're making sure that our real laser and our red dot are in alignment together. So while we are in beam alignment mode, we can simply tap the up key on the display, and that will fire the laser beam. And we can see what that's doing is that's firing, pulsing that laser at low power and telling us where that's hitting the target bullseye inside the lens assembly. So by our first point, we have fired the laser beam, and we now have our glass open, and we're getting a finer look at where the burnt spot is on our bullseye target. And we're finding that our real laser beam is actually in alignment. It is in the center of our target. Now, as we look at the red dot, that's a little off center. So we would want to use only these screws on the red dot pointer to adjust the red dot and move that to the real laser beam. Let's do that now. So as we adjust the screws on the red dot pointer assembly, we're only going to move the red dot, not the real laser. And so as we move that red dot's screw, that move the red dot to that direction. And there are 3 screws that move it in 3 different directions. So you make small, fine adjustments to those screws to get the red dot where the burnt spot is on the tape. Now that we have our laser beam and our red dot pointer aligned together, we're going to verify the alignment as it moves across the table. Okay, here we have positioned our lens assembly in the back left corner of the table. And again, the upper left hand corner is going to reference to one of the mirrors in that back assembly we referenced earlier, that mirror number 1. Therefore, we have one mirror to go with each corner of the table. As the lens assembly is in the upper left-hand corner, we're using only the alignment screws of mirror number 1, which is the mirror on the bottom. Then we move the laser's lens assembly to the front of the machine, to the lower left corner, and we're verifying that the laser beam is not moving, that it's staying in the center of our target here. If it stays in the center or parallel as it moves front to back, there's no need to go any further. If it is off, we're going to adjust each mirror in the assembly as it references the location in the correct corner. So again, we adjust mirror number 1 to reference corner number 1 till the red dot and the laser beam are in the center. And then as we move that to the front, lower left corner, if it is off, we're going to use the upper top mirror to make any adjustments till that red dot and laser beam are in the center of the target in this corner. And we're going to push this back and forth, ensuring that that stays parallel with the table. If it moves or changes position, if the red dot or real laser change position as it moves from corner to corner, you're going to continue that process of making small adjustments to each mirror in the corresponding corner. The goal is that as you move the lens assembly front to back, that stays parallel with the table, and your laser beam and red dot pointer are staying in the center of the target as it moves front to back. That's all there is to getting the front to back aligned using those two mirrors. Okay, so now that we have verified that the lens and the laser beam are aligned as it moves front to back inside the machine, now we want to verify that the laser, red dot pointer, and the real laser beam are level as it moves, as the lens assembly moves left and right across the table. So we do that as we're still in alignment mode. We can take this by hand and move this to the other side of the system. And as we move that, we're verifying that those beams, the red dot pointer and the real laser beam, are staying in the center. Now if you need to make another mark, you can tap the up arrow key to fire the laser, and that will fire a burnt spot on the tape. If the real laser and the red dot pointer are not staying in the center of the target, maybe it's okay on this side but off on this side, then you're going to use this steering mirror that's on the x-axis carriage. You're going to use that 3/32 Allen wrench and make any adjustments needed. So you would adjust the screw here, here, or here till you steer the red dot pointer and the real laser beam in the center of that bullseye target. And you want to verify that it is staying center as you move that by hand all the way down the lens assembly. This is getting that laser beam parallel to the table as that moves left and right across our table and workspace. So there you have it, ladies and gentlemen. To perform a beam alignment on this particular model, you're using the up key on the display to fire the laser beam, and in alignment mode you're able to move by hand the lens assembly in each corner. You're verifying that that red dot pointer and the real laser beam are staying consistent in the center of the target, and adjusting the corresponding mirrors we just reviewed. So after you have verified that that's in the center of the target and each corner, that's all there is to it. You can simply remove the tape
and remove the Bullseye Target.
Then at this point you can push the stop key on the display, and that will move the carriage back to its factory engaged home position. So that's how you perform the beam alignment on the Mini 18, Mini 24, and Helix. I hope this was helpful.